All right, Algebra 2, Unit 2, Targets A and B Study Guide. All right, so number 1 says determine the key features of the following quadratic function. We're given the equation f of x equals negative 1/4 quantity x plus 4 squared minus 6. All right, so first thing you want to notice is that they gave this to us in vertex form. Okay. And vertex form is y equals a parentheses x minus h squared plus k. Okay, so vertex is going to be the opposite of h. So because it's positive 4, when we pull it out, it'll be negative. Case is the same for a negative 6. Okay, we can go ahead and plot the vertex. Negative 4, negative 6 will be this point right here. Okay, axis of symmetry is just going to be the x value of your vertex. So x is equal to negative 4, right? So if we wanted to draw the axis of symmetry, it's that dashed line that creates symmetry from left to right and that runs through the vertex. Minimum, maximum, the fact that A is negative 1/4 tells me that it is a maximum. And the max value is the y value from your vertex, so it'll be y equals negative 6. Okay. Your y-intercept, for this one, we just have to let x equal 0. Right? Because if it's going to cross the y-axis, that means there's no left to right movement. It's directly on the y-axis. So if we plug that in, we have y equals negative 1/4, 0 plus 4 squared minus 6. Okay. You could put that all into your calculator at once. If you do so correctly, you should get a y value of negative 10, which tells you that the y-intercept is at 0, negative 10. So we can plot that point too. 0, negative 10 would be right here. And then let's go ahead and graph it. Okay, so we know it looks like this in this direction. The fact that there's a point at 0, negative 10 tells us that at negative 8, negative 10, there's another point when it goes down that way. All right, so your domain, as is with all quadratics, will be all real numbers. Your range, how far down it goes towards negative infinity, how far up it stops at the y value negative 6, actually touches it, so bracket. All right, number 2. Now we're given a quadratic, but it's given to us in standard form. So it's a little bit different. Okay. Standard form is y equals ax squared plus bx plus c. Your y-intercept is just going to be your c value, so that's going to be the point 0, 1. We can go ahead and plot that. On the y-axis, we have a point right here. Axis of symmetry, we want to use the formula x equals negative b over 2a. B is negative 8, so we're going to have a double negative in the top. A is 2. If you go ahead and simplify that, negative 8 gives you positive 8 divided by 4. It's going to give us a positive value of 2. So your axis of symmetry is x equals 2. So again, if you wanted to graph that, that just means our line of symmetry will be going down the x value 2. All right, your vertex, we already know the x value, so we're going to go ahead and let x equal 2, and we're going to plug that into the equation. So we get y equals 2 parentheses 2 squared minus 8 times 2 plus 1. You can put that all into your calculator at once. If you did, you should get the value negative 7, which tells you that your vertex is at 2, negative 7. So if we plot that, 2, negative 7 would be right here. Max or minimum, A is positive, so that tells us that it's a minimum, and your minimum value is going to be the y value from your vertex, which was negative 7. We can go ahead and graph this. Okay, so we know the left side looks something like that. And then because there's a point at 0, 1, and there's symmetry, that tells us that at 4, 1, there's another point as well. Your domain will be all real numbers. Your range, how far down, it goes to negative 7 in brackets, and then how far up towards infinity in parentheses. All right, number 3, now we have factored form of a quadratic. So again, a little bit different. Factor form is y equals a parentheses, sorry, that's x minus p times the quantity x minus q. X-intercepts will be the opposite, so if it's positive 2 in parentheses, that means it's going to be negative 2, 0. And the other one, because it's minus 4, will come up as positive 4, 0. So we can go ahead and plot those on the x-axis, negative 2, 0, and 4, 0. All right, to find the y-intercept, we need to let x equal 0. We plug that into the equation, so we have y equals negative 0 plus 2, parentheses 0 minus 4. If you enter that correctly, 0 plus 2 gives you 2, times a negative 1 gives you negative 2, times negative 4 gives you a positive 8, which tells us that there is a y-intercept at 0, comma 8. So we can go ahead and graph that as well. X is a symmetry. For factor form is a little bit different. The formula is x equals p plus q divided by 2. P is going to be a negative 2. Q will be a positive 4, all divided by 2. X is a symmetry will be at the x value 1. So we can go ahead and draw that line, that dashed line. Vertex, we already have the x value, 1. So we just had to let x equal 1. Plug that in. We're going to get y equals negative parentheses 1 plus 2, parentheses 1 minus 4. That's going to give us the value 9, which tells me that the vertex is at 1, 9. So 1, 9 will be right here. Minimum or maximum, it's a maximum because a is negative. It's a negative 1. That tells me that it will be a max value. The y value from the vertex is 9. All right, so the left side of the quadratic looks like that. Because we have a point at 0, 8 and there's symmetry, that tells me there's another point at 2, 8. Okay, domain will be all real numbers. Range, how far down towards negative infinity. How far up to the y value 9, which it actually touches, so brackets. All right, number 4, we want the equation of the quadratic in vertex form. So keeping in mind vertex form is y equals a parentheses x minus h squared plus k. So in the vertex, we're given hk. In the point, we're given x and y. So for y, we'll plug in 23. We don't know a. For x, we'll plug in 2. Opposite of h, so that's going to come in as a positive 1. And then k was a positive 5. All right, so 2 plus 1 inside the parentheses is 3. 3 squared is 9. 9 times a gives us 9a plus 5. If we subtract 5 from both sides, we get 18 is equal to 9a. If we divide both sides by 9, you get a is equal to 2. So then we could finally plug it back in. It's going to be y equals 2 parentheses x plus 1 squared plus 5. That is vertex form and what we were looking for. All right, number 5 says rewrite the equation in standard form. So we have an equation currently in vertex form, but they want it in standard form. So they want it as y equals ax squared plus bx plus c. All right, so what we're going to do here, it's like expand it first. So we have y equals negative 2x plus 4. We're going to multiply that by itself twice, just like the exponent tells us. I'm going to go ahead and distribute this. Negative 2x, negative 8. We want to multiply all of that by x plus 4. And there's still minus 1 on the outside. So we'll do negative 2x times x, which will give us negative 2x squared. Negative 2x times 4 will give us a minus 8x. Negative 8 times x is negative 8x. Negative 8 times 4 is a minus 32. And the minus 1 that was already there. All right, combine like terms. We have negative 2x squared. The negative 8x minus 8x gives us minus 16x. Negative 32 minus 1 is a minus 33. So my equation in standard form is y equals negative 2x squared minus 16x minus 33. All right, rewrite the equation in standard form. They gave it to us in factored form. And again, we want standard form. So we want y equals ax squared plus bx plus c. So we're going to distribute. We have negative 3 times x is negative 3x. Negative 3 times a negative 1 is positive 3 times the quantity x plus 7. So negative 3x times x, negative 3x squared, negative 3x times 7 is a minus 21x. 3 times x is positive 3x. 3 times 7 is a positive 21. Let's combine like terms. Negative 21x plus 3x will give us negative 18x plus 21. So our equation in standard form is y equals negative 3x squared minus 18x plus 21. All right, number 7, they want factor form. A times the quantity x minus p times the quantity x minus q. Okay, so we have p, we have q, we have x and y. So for y, we're going to plug in 45. We don't know a. For x, we're going to plug in 2. Take the opposite of p, so that'll be positive 3. For x2, positive a q minus 5. So we have 45 is equal to a. 2 plus 3 is 5. 2 minus 5 is negative 3. Multiply those three together, you get negative 15a. Divide both sides by negative 15, you get negative 3 is equal to a. We can finally plug that in. So y equals negative 3, parentheses, x plus 3, x minus 5, and this is factored form. So final answer right here. All right, number 8 says the function f of x equals negative 8x squared plus 480x minus 4,608 shows the profit that a dance company earns for selling tickets at different prices. What is the maximum profit the company can expect to earn? Okay. So notice they give it to us in standard form. So y equals ax squared plus bx plus c. A is negative, so that tells me that I have a parabola that opens downwards. So my vertex here is a maximum. Okay, so we have x as our input and y as our output. So what we plug in, x is the price of the selling ticket. So price of the ticket, and y will be the profit. Okay. So when they tell us that they want the maximum profit, they want the vertex, but specifically from the vertex, they want the y value. So first I need to find the x value. So technically, in finding the x value, we're going to use a formula for x is a symmetry. Okay, which tells us that x is equal to negative b over 2a. All right, so b in this equation is 480. 2 times a is negative 8. All right, you do all that, you should get a positive 30. Okay, so from our vertex, we know that the x value is 30, but we still don't know what came out. So we're going to let x equal 30. Plug that into our equation. So we have y equals negative 8 parentheses 30 squared plus 480 times 30 minus 4,608. That should give us a y value of 2,592. So we know our vertex is at 30, 2,592. So what's the maximum profit? Profit is $2,592. All right, number 9 says write the equation in standard form of parabola that passes through the points. We have 3 points, which technically is one more point than necessary. The only issue with this one that makes it different from the other ones is that we don't know if any of these are x-intercepts. Well, they're definitely not x-intercepts because there's no y values of 0. There's no y-intercept because none of them, the x is not 0. We're not told if it's a vertex, so we can't just plug in values. So for this one, we're going to have to do quadratic regression. In our calculator, you're going to want to go to Stat, press Enter because we want to edit. If there's something already in your list, all you need to do is go up, put your cursor over L1, clear, and then Enter, and it erases everything. Go ahead and erase L2, clear, and then Enter. So back to L1. The first point we had, negative 15. And that went with the the y value of 105. Normally I would enter all the x's, but if you want to make sure that you don't accidentally enter it in the wrong location, this might be a way to do it. The next one was 5, negative 75, so 5 here, and then negative 75 over here. Okay, so we have negative 15, 105, 5, negative 75. And the last one is 35, negative 1095. So for there, 35, enter. And for L2, it was negative 1095. If you have values that are bigger than 1000, don't put the comma because some put a comma between the 1 and the 0. And sometimes it'll think you're entering two numbers. It'll think you're entering negative 1 and then 95. So just leave it without commas. And then from here, you're going to want to go to Stat. We want to calculate, so click to the right. And then when we want option 5, which is quadratic regression, so you can either click 5 or arrow down, click enter. With the 84 pluses, you're going to have to go all the way down to calculate. Press enter again. So we knew that A was negative a half, or 0.5. B was negative 14, and C was a 7.5. If you plug that back into standard form, you have y equals negative 0.5 x squared minus 14x plus 7.5. Final answer.